All right. Hello and welcome everybody to the Argo CD and Rollouts community meeting. Uh, just as an FYI, we adhere to the CNCF Code of Conduct in this meeting. Um, we have one thing on the agenda for today, which is a demo of an Argo CD diff preview project, which I will basically just hand it off to Deg and let him go with it.
Thank you. Thank you. Thank you so much for wanting to see a demo of this and also hear about the project, which I've been working on for a few months. I have prepared a few slides just so you have an idea of what I'm talking about. If for those of you that didn't at least click the link in the meeting working document, whatever. I hope you can see my screen.
Yep.
Can anyone confirm? Thank
Yep.
you. I hope this can be more of a discussion rather than just a presentation of something. So please feel free to ask as many questions as you want and so on. But otherwise, I'll just go through the slides of the tool I made, and yeah, we can use that as a basic for the conversation. So I've created a tool called Argo CD Diff Preview, and I did that I originally created it as a prototype for my previous workplace. And then I thought it was so cool that I wanted to create it into a proper open source project. And before going into the tool, I rather want to just highlight the problem I'm trying to solve. And you have probably seen this a billion times before. So if you've worked with any kind of GitHub tool, then you have probably received some kind of pull request that says like, oh, I just updated a replica, set it to 5, like as a Helm value, or I just updated a Helm chart version, or I changed something in a base folder in some customized files. And what is common for all three is that you don't really know what's going to happen once you merge it. Like you hope that the person that updated the Helm value actually like wrote it correctly and it's called edit, like they maybe it was called replica count instead of replicas, but you don't really know that as a reviewer. And the same thing with customize. If you change something in a base folder, you don't necessarily know which overlays it impacts because it could potentially also be overwritten by later overlays. Anyway, I guess you have seen the problem before. You don't know what the rendered outcome actually is. So therefore, I have created a tool that is fairly simple, I would argue, and it creates like these kind of comments on your pull request. It gives a nice little summary, and then it renders the diff that has changed from that will go live once you merge your pull request. And the way it works is fairly simple, I would say, that you as a developer, you create a pull request, then you have some kind of CI tool that starts a local ephemeral cluster inside your pipeline. It installs Argo and applies all your applications to it. Then we extract all those manifests that Argo generates and just post them on the pull request. That's the overall design of it. And in more detail, what actually happens when after it had created the Argo cluster, it goes through all your applications in that GitHub repository. And let me just move one of these windows so I can actually see what's going on. So first of all, it sets the project to default. It removes the sync policy to make sure that we don't accidentally sync anything inside our little local cluster. We change the destination from whatever it was set to in cluster. And then we change all the target revisions to the new branch you have created. So this way we collect when crawling through the repository, all the applications and make sure they all point to the branch that you want to test for and like change the destination and project just to make sure that Argo doesn't complain because they don't exist inside your temporary cluster. And after doing so and applying it to Argo, Argo will do its magic and then it will render all the diffs and so on that you would usually see through the UI. But instead we just run Argo CD app manifests and then extract all those rendered manifests out and save it in a file. After you have done that on both your pull request branch and your main branch, well, then we can just do a git diff and compare those two together. And this way you can see exactly what will be changed by rendering the whole thing. And since it's like Argo rendering it and not your custom script or some other kind of system with multiple PRs or whatever, that means this is exactly what Argo is going to render for you because it's Argo that renders it for you, right? So it's fairly easy to use our Argo because all you need to do is, for example, here we have a GitHub workflow example where we pull down the pull request branch, we pull down main branch, and then we just run the tool, which runs inside a Docker container, and it creates some kind of markdown file for us, and we just comment it directly on GitHub. So that's how easy it is to use. And this, I believe at least, that you could copy paste this in any repository which is public and only uses public what's called Helm charts. Yeah. So far, I have only talked about what happens since things are public, because then Argo can just take a look at it without needing any access credentials. But if you do need some kind of credentials, well, then you need to give the tool the secrets and like mount those secrets into the Docker container. So in this case, since you probably, as your professional organization, you have these private repositories, and therefore you need to at least store the private repository secrets inside a file, raw, and just like mount them in, as I said. Or if your pipeline actually has access to your real live cluster, which is running production, the real one, then you could just run like kubectl get secrets from the Argo namespace and just inject it directly into the container as well. And that way these preview clusters always have the same credentials as your live infrastructure, meaning that you always get like exactly the same rendered output as you would do if this was live and not just in a like render demo. I hope that made sense. Otherwise, feel free to ask questions. I will also go through it later probably. It's only a few slides. Just a few notes for myself here. So first of all, what I really like about it is it's very easy to set up. Like you saw, this is not a lot of stuff to set up. Like compared to a lot of other tools that exist out there, would you have to install things on the cluster, you need to give it credential, you need to add webhooks and create multiple PRs, who knows. This is for sure the simplest solution I've seen so far. I'm very happy about that. One thing that I'm also happy about is that this system only compares desired states. So we're not looking at anything that actually runs in your real cluster that Argo synchronizes with. It only looks at two branches, and that's the desired state. And why is that important? That's important because some of the other solution or tools that exist with this that use I don't remember the exact command, but Argo CD something apps diff or diff app or something. I don't remember it exactly, but that one, as far as I remember, like I only have pretty bad experience with it, sadly, but it's something where it shows you the diff between what you locally have on your in your local directory and then what actually is synced on the cluster. That means if you have something in your live cluster that are not in sync yet, that will always like be pointed out, being like, oh, you're out of sync with production because production was never synced to begin with, meaning that if I did everything with this Argo's app sync whatever command, then everything that was not completely in sync when I ran the command would be highlighted as, oh, there's a diff change. Anyway, the main thing is here, like, for example, if you have used Terraform and you run like Terraform commands, you will notice that sometimes when you run it, it actually gives different output. It's never deterministic because things could have changed in the real cloud out there. And this way, it's always deterministic because it doesn't have any real state. That makes sense. I think that's kind of great. Another thing I think is nice here is that your PRs do not need to be up to date with main. And this is, again, I'm just constantly making comparisons to Terraform here. But for Terraform, for example, like it needs to be, you always need to be up to speed with main because otherwise, like it can't really merge the conflicts correctly and so on. And here, that's not the case. You can have very outdated branch and it still works. Yeah. Whoops. Yeah, you can also run it locally. I think that is quite nice. Before you actually open up a pull request, then you can just run it locally in your branch, see what it prints out, and so on. Another thing I really like is that you don't need real access to your infrastructure. your real Argo instance doesn't even need to be running in order for this to work. That's why I can do it on like completely dead repositories that have been abandoned for years, probably. You can just run it on it and it just spins up a local one and does whatever it needs to do. Again, it just ties into the simplicity. Another thing I wanted to highlight was that even though that I make a lot of comparisons to Terraform, it's also a bit different in the way that, so if you have a branch that is very outdated, no, let me start another way. This tool only shows the diff between two branches. That means that if your branch is heavily outdated, let's say it's 200 commits behind, then the diff will be very big. And thus it looks like, since your branch is behind, it looks like it's like reverting all those changes, because like it doesn't show you what's going to happen necessarily. It only shows you the diff between the two branches. So it could look, if you have very old branches, that your branch is essentially reverting all the changes because they are not on your branch. So when the diff happens, it's rather big. Anyway, it's a detail, but I just wanted to note it here, that that's at least a little bit of the drawback compared to Terraform. Yeah, why was this created? I just want to answer this because we had this problem in our organizations that our developers didn't really care about like manifest and so on. They were just introduced to Argo, and I could already imagine that once they got introduced to it and they broke it the first time, they started hating the tool. So we didn't really want that. So I tried to make a tool that could actually just render these changes as we just saw, and it at least catches multiple mistakes on a daily basis. So I think it has been rather successful. And originally it was just created in Bash and make files, and it got the job done. It was not super pretty, but it worked. And yeah, just to show that this solution also scales fairly well, at least. We had like our whole setup was that we have 900 Argo applications running in a single Argo instance, and it was like in a mono repository. If you only change a single Argo application, then it's kind of wasteful to go in and render 900 applications each time. It takes forever in that case. So what we did instead, or what the tool supports, is that you can give it a regex to define what files it should be run on. And to give it a little example of that. So the way we have structured our files in this mono repository was that each team had a folder, in both a folder where they had their Helm chart values or customize or whatever files. That's what you see here on top. And then there was a folder where each team had their applications or application sets, like split up in this case. But the main point here is that every team have a folder, have everything that teams can change is in their folder. And this means that if someone in team B makes a change to either their application or their values file that those applications use, we can just provide the tool with a file regex, meaning like look only in team B folder. And that way we make sure that we only render those applications that has been affected by those changes. Yeah, so at least that helps with the scalability, because otherwise it will gonna take a long time to render. Like it takes a lot of seconds to render 500 applications, and that's just because Argo takes time to run. Yeah, just have a few slides more. So one of the challenges that I hope maybe one of you experts can help me discover or solve is that when this tool runs, and in this case, I'm running it on 700 applications, so a lot of them, then I'm like slowly asking Argo to process them inside this tool. And for some reason, it often just stops doing anything for, like, in this case, 50 seconds. I don't really know what Argo is doing in these kind of 50 seconds. If there's like some loop that it's just waiting to happen, or there's some, I don't know. I have no idea. That's at least a discussion topic, because I really try to change a lot of the variables inside Argo. Like you can tweak how many parallel threads that run, the timeouts and so on. And I couldn't make it actually not do this randomly for 50 seconds, which slows down the process quite a bit. Another thing is that, which is probably the most nasty part of the implementation, is that I'm like hard coding error messages inside the code here, this could be prettier. But I just wanted to show some of the pain points of actually trying to build this tool, because if you ask Argo to render 900 applications, you will realize that no matter what, some of them will fail. And that's mostly just because there's timeouts and other stuff. You probably also see that in production if you start to apply 900 at the same time. But in those cases, I don't really want to throw an error to the user running this tool because it's a timeout. We just need to wait for another cycle to actually refresh, and then it works. So in those cases, I have like a little list here at the bottom where if this includes the word timeout or a client timeout or something, let it pass. Otherwise, if it like complains about a real error like authentication required or failed or something, then let's just exit out early. There's no reason to wait for the whole timeout and like run for multiple minutes. And this is only the errors I have encountered when actually developing the tool. So each time I encounter a new one that should be in the error message collection here, I'll just keep adding it. But this, I have no overview of which possible errors can actually happen. Yeah, this was just my last slide where I wanted to show some of the pain points, at least, building this, because it's a wrapper around another tool that produces random errors for you to catch. Worst case is that if I have not declared any error message here, it will just print them all to the user once the tool is run out of time. Anyways, this was my few slides here. I hope you enjoyed it. I would love to hear your opinion on anything related to the tool or the problem in general.
Thanks, Dag. There are a few questions in the chat. If you could take a look, please.
Oh, how do I bring this up when I'm sharing screen? Here we go. I should probably have looked at that while actually going through it. Oh, there's the question about how is the speed. I will go back to that slide in a second. Yes, the speed is a problem here. So because spinning up a local cluster, spinning up a local cluster takes time, and installing Argo CD also takes time. That means at a minimum, it takes like around 70 seconds just to render a single application. So yeah, that's kind of annoying. That's mainly just for Argo to actually wake up, because like it needs to synchronize, it needs to go, yeah, back and forth, whatever. Argo takes time to start up. So at a minimum, it takes around 1 minute, and then it's pretty much a linear scale from that point on, when Argo just crunches through all the applications you ask it to render. That's the speed problem here.
How does spin up time compare to crunch time? Is it like half and half, or is it mostly spin up time until you get to like thousands of apps?
So it depends on how many applications, right? So if we look at this graph here, at least if I have to trust my own numbers here, at the point where you hit around 200 applications, then it's an equal amount how much time you spend on actually spinning up the cluster and actually rendering the actual manifests.
I got
So
you. Start at 70. That makes sense.
Yeah, something like that. I have no idea how to speed up this process. I really hope to speed it up, and a lot of the speed problems actually comes from this, where it just stops for 50 seconds. And I don't know if it's like because I'm hitting some kind of limit on, for example, GitHub or something, and it's like giving you a slower response or something. I don't know. And then after those 50 seconds have turned out, well, it just quickly runs through the rest. But that's the main speed problem. Yeah, I hope that answered the question.
Yep. And I've got ideas about how you could speed up the actual crunching and rendering the manifest. I have no idea how to spin up kind faster, so that would take some research, but I can help on the second half.
That sounds amazing. The tool also supports what's called Minikube as well, in case people find that faster. It's usually the same, but then there's a question related to the diff tool. Oh, maybe I should actually do a real demo here instead of just looking at slides. I actually forgot about that. Should we make Zoom really confuses me with this multi-screen setup where the windows jump back and forth all the time. Because now the chat disappeared. There it is. So yes, I actually looked at these kind of other diffing tools for doing a nicer diff. I played around with it. I did not get super great results with it, but it's probably just because I'm bad at or actually configuring it correctly. So it's only a matter of time before I actually give it a proper look and actually make it look nicer. Oh yeah, some of the problems that were with these other fancy tools, I don't know. Maybe it was this tool, I can't remember, but well, there was one of the very, very pretty tools that makes some diff and it does everything with like nice coloring and so on. But the problem is that when it's just raw markdown files, that means colors are not supported like they are in a terminal. So these tools that make it look very pretty doesn't look very pretty when you actually make it into markdown and put it on GitHub. That's just a small comment, and that's where I actually left it. But definitely a place for improvement as well. Then there's a question, does it detect diff for apps generated by application sets? Yes, it does. So far, I have not seen anything that it doesn't catch. That's not true actually, but let's go back to that later. Here is the repository, and just to have some more examples, let's just show these here. I have them on the branch, on the pull request and the repository, where here I have a pull request where I make a change to a replica count, and I also make a change to whatever full name override is. I think this was just a default Helm chart that it generates. And then we can see correctly that it highlights that, hey, you updated this name and you updated the replica count. This is the most basic example. You can see it rendered here. Let's take another example. There's the one with Nginx. In this case, I'm downgrading it. You can see exactly what changed, and maybe it's not super critical to know that it updated the version here, but what is actually could be critical is to see when it actually changed the default behavior. So for example, this one here, in case you had something that depended on this. Anyway, just another example. And the last example with the customize is this one. Oh, here's another example. In this case, just for the fun of it, if you got a pull request that looked like this, hey, I'm updating this replica count equals 5 here, or sorry, replica is equal 5, it may look correct, but when you actually go here and look at the diff, it says no changes, meaning that clearly you wrote this key wrong and it should have been replica count or something else. So it's also very good at actually like catching no changes. Yeah. Before looking at more questions, maybe I should just like run a quick demo of it. So if we open up here, I have opened the same example from the pull request. Here I have just both some customized example and some Helm examples. I just have this auto-generated diff, chart. And in case we wanted to see how it works, if I like, for example, update the pod labels, if let's say I want to do that, I can add it here just as an example, and I can add whatever Copilot suggests to me. Let's say now I have made these changes and I want to see how that actually impacts the system. I will create a pull request for exactly this. Give me 1 second. Do it on another screen. Let's also, for the sake of it, update the name. So here I have the pull request that I just changed. I added whatever labels happened here. And now we expect that it will come up with some kind of preview here for us. And yeah, we'll just let this run in the background and you will see how long it takes. Feel free to unmute and ask the question while I once again fumble and try to find where those chats disappeared. Jesus. Then there's the question, what is your thoughts on the rendered manifest pattern and how does your tool have a function in that pattern? Are we referring to the same kind of pattern that Nicholas talked about at KubeCon? And correct me if I'm wrong here, it's about that you render manifest and store them in, I can't remember if it's another branch or another repository, right? And then you have like an intermediate step where you can see the final one. So you're not really relying on Helm to render and customize to render it live. It only does that in the pre-processing phase before it actually, right? Yeah, I'm looking at Nicholas nodding. Yes, great. In my mind, you don't need that pattern when you have this. I still think there's definitely other benefits for doing the other temporary step. For example, Nicholas talked about that it takes a very long time to actually build all these Helm charts and so on. So in this case, you are not solving that, but you could solve it by using that rendered manifest pattern. Besides that,
like, and the immutability of the desired state. If you pre-render the manifest, then there's no chance for them to change in the cluster. But I agree with your sentiment. Like, this tool removes a lot of the concerns, at least especially the end user facing problems of like they don't know the impact of the change that they're making.
Yeah.
So I have a question. I haven't really. I've read what you posted here. I haven't gone to it deeply, so sorry if my question's a little ignorant.
No worries.
So the only thing. So I like the rendered. So this has to do with rendered manifest because part of the challenge with rendered manifest is if you're using OCI. So like if you render your manifest and you put them in OCI, there's no way for me to see a diff between you know what's gonna be put in OCI versus what's in OCI, right? So like what I like about rendered manifest, like if I'm putting it in Git, like I can see the diff as a whole. And so can this diff tool help in OCI? Like if I'm rendering my manifest in OCI, can this tool help in that diff, I guess? So like how do you like, have you put in much thought into like these manifests being in OCI and how you diff them from OCI?
I gotta be honest, I don't know much about the difference between how manifests are stored in OCI versus not being the case. So
yeah, well, because I'm trying to think like a workflow in my head because like, okay, I rendered the manifest, I put them in OCI, Argo deploys them from OCI, potentially, right, from OCI. Now I'm trying to see a diff of what's gonna be in my repo versus what's running on the cluster. And so I guess what I can do is I can just quote unquote trust. I mean, I guess we all do Argo CD at that point, and then show the diff because what you're diffing is what's running in Argo. Is that correct? Like you're diffing, okay, like locally.
Yes.
Or like you're diffing locally what's running quote unquote in Argo. So at that point, I guess I can see the diff before I either push it or create a PR.
Yeah. So just like your live real Argo instance, this one renders exactly the same thing, hopefully at least. Like it's running the same version and your and you're getting it this, providing it the same kind of information, so you're giving the right credentials. So I guess in theory, at least, it should create exactly the same thing that the real Argo cluster would render. So if you could see whatever you're trying to render inside the Argo UI when things are not in autosync, that would be the same thing as this tool produces for you every time. So I believe this also works for your case.
Yeah, it does actually, because I was thinking, well, maybe I can query OCI, but if I'm trusting Argo to deploy from OCI, I'm just using Argo as an interface into that OCI. So yeah, okay, I'll play around with it. Yeah, and if I have more questions, I'm gonna bug you on Slack. So cool.
Please do, please do. One thing I really want to stress here is I have very limited code repos available to me, so I have just run it on all the cases I can find, and I've only fixed like issues once I encounter them. So if anyone experiences any issues with this, like, please let me know so I can try to fix it. I only want to make it better. But I only have so much code available to me. Any other questions? Would it work with applications that for Git generators where app sets and actually are different repos?
Think
To the question,
wouldn't that only
no.
work on like you'd be running that pull request on only one of the two repos, either the one with the values or the one with the Helm charts. So you'd only be able to check the diff for that specific pull request, not the aggregate of both.
Yes, that's how it works right now. But it's no problem that your values you're referring to in your applications exist in another repository, as long as the secret you give it also have access to that repository. Then that is no problem.
I think that's definitely the most beautiful part of this implementation is that like you don't have to, if it works as an application in Argo CD, it'll work with your tool. So config management plugins, multiple source applications, application sets should all just work, assuming correct credentials.
Yep, for sure. One thing that happens sometimes is that people get false sense of security here. So because your like YAML is correct and Argo understands it, doesn't mean it runs, right? Because, for example, once you actually click sync on something, it'd be like, oh, you don't have permission to actually create this kind of cluster role binding or something, or this container can't start because you're running as admin and that is not allowed, something like that. So you can still like merge YAML that doesn't work, but at least it's valid. It just doesn't work as you expect.
It's more analogous to like linting than it is validation.
Yes. And so far, when doing the development of this, there's so many times I'm like, no, this must be wrong. Like the tool, there must be a bug because my code is perfect. And then after doing a lot of debugging, I realized actually Argo always produces the right results. So it's actually my code being wrong, not the tool. But that happens very often, at least. Any other questions? Any other thoughts?
Going once, going twice.
That was the question I skipped, sadly. How many commits did your testing monorepo have? Have you found a repository up to bottleneck? No, I have not had any repository operations bottleneck problems at all. The biggest, biggest repository that I ran this on had like 10,000 commit or something. It was not an issue. When you actually run the, maybe this is a question for more Argo inner workings that I don't know of, but at least like at least when you're pulling it, you're only pulling the newest commit and not the whole tree, or at least you can do it like that, and that creates pretty much no problems. Maybe if your tree is gigantic, it's a problem, but otherwise I don't know. yeah, that's pretty much it.
Great. Well, thank you for presenting this. I'm sure many people in the audience will be interested in trying this out for themselves. I imagine pull requests and issues are welcome.
Please, please, please. Also, just open an issue and I'll try to fix it. No pressure to actually fixing it yourself. I will happily do it.
Even better.
I just need people to report issues so I can fix them.
Just need users now.
Yeah. Extra stuff, since we you can specify how many lines above and below that change is highlighted. That's sometimes useful, because if it's too small, then you can't see what's actually happening. Just a small thing. It automatically truncates to the max length of GitHub. And that's just because if you change a big Helm chart, it's very often that it like produces the biggest diff in the world. And then GitHub complains because it's too big. So in this case, it just writes like truncated to fit. And then you can either run it locally or you can just merge it at smaller times. But that's more of a GitHub issue than the tool. Oh, one big thing I actually forgot is that when we use this, we of course constantly, like, people push new images all the time, right? So those images has to be checked into those million staging environments we have and so on. That means that our main branch are getting like bombarded with new commits all the time where people just like bump these image versions. So that means if you create a pull request actually going into this, into your repository here, you would, if you look at the diff, see like a billion image updates that happened, like, because that's the difference between your main and your branch. That would, of course, be super annoying when you have 900 applications that constantly go out of sync. So that's just like I did with the other regex. There's a one called, let me just, not this one, diff ignore. And this is where you give it a regex to ignore certain lines. This is exactly the same thing that happens when you write git diff ignore something. So in this case, what we did was we tagged everything with the same like kind of convention. You could do semver or whatever you like to do. You just put it here in the regex, and that means it ignores all lines that have those image things, because otherwise that will for sure be a problem. Yeah.
It's great. All right. I think we'll call it there. Thank you everybody for joining the community meeting, and thank you, Dag, for presenting. Yeah, we'll call it there. Thanks, everybody.
Thank you.
Thanks.